All right, how's everybody doing? Professor Brian back with another installment of Workout Wednesday. Today we're going to be doing some stuff in the organic chapter. That'll be chapter 24, specifically nomenclature on alkanes, alkenes, and alkynes, also with substituents, proper numbering, etc. So let's take a look at some of the examples that we want to work with. And I have went ahead and told you guys that when dealing with these, there's a couple first things that you want to be able to do. And I always just, for practice purposes, go ahead and verify that you can write the condensed formula for these. And I'm going to show you the condensed formula. If we wanted to write from left to right, the condensed formula would be CH3. That's that last carbon. Then there's a CH2. Then there's the CA, the C that's triple bonded. So we got a CC because we got a triple bond here and here. Then we have a C with two ethyl groups on it, CH2, CH3. And you can put those in parentheses or you can put those as a side chain. And then we have a CHCl. That's this guy, and then we have a CH3, right? You can also write this CH3, CH2, CCC, and then you can make two ethyl groups, like such. And then you can go CHCl, CH3. You might also see it written that way. And I'm sorry, it's kind of I kind of got it a little small, but you should be able to see that the two side chains, right? Okay. So when it comes to numbering and nomenclature, let's see if I can maybe use a different color here. The nomenclature needs to occur, which is going to give you the closest to the suffix, right, from a priority standpoint, which is the triple bond. So 1, 2, 3 gets us the triple bond here. If we go from this end, 1, 2, 3, 4 is 4. If we go 1, 2, 3, 4 from the side is 4 as well. And what we don't want to do is pick one of these two ethyl side chains to start our numbering from, because that makes the substituent here different side chains. So what we want to do is actually number from this side. So our numbering will give us a 1, 2, 3, 4, 5, 6, 7. Okay? And it is also the longest. 1, 2, 3, 4, 5, 6, 7 is the longest, and it is numbered in the correct order. Okay, so from here, we want to take a look at the substituents and side chains, which in this case we have a chlorine here, and we have two ethyl groups, right? CH2, CH3, right? So we have two ethyl groups and a chlorine, and A, B, C, D, E. So C comes before E. So in the nomenclature, remember it's alphabetical order, so we're going to start with 6 chloro, and we've taken care of the chlorine here. 5 diethyl, because we have two ethyl groups. And then again, I've shown you can do two different ways here. You can go 3 heptene, or it's also correct to go 6 chloro 5 diethyl hept 3 ene, right? Both of these are acceptable, right? Both of these are acceptable. Okay. Again, excuse me. I made a mistake. This should be yne. Excuse me. This should be YNE, right? It should be YNE because it is a triple bond. Excuse me on that one. It should be heptyne. And again, how quickly you can make a mistake. Make sure that you are extremely conscious and go back and double check. This is heptyne because of the triple bond, not ene. Ene is for double bonds. Getting ahead of myself. Okay, so now let's take a look at B. Take a look at B. B has two double bonds. The longest chain involves 1, 2, 3, 4, 5, 6, 7, where our suffix is going to be ene, in this case, ene, and therefore our numbering should start from the left here as well. 1, 2, 3, 4, 5, 6, 7. So we also have a situation where we have 7. Now we have two substituents here. We have a methyl group here and a methyl group here, 6 and 5. And we have our suffix, which is going to be ene. So since we only have two substituents here, side chains, we have 5, 6 dimethyl, right? 5, 6 dimethyl. And then we have 2, 4 heptadiene, where the di is because we have two double bonds, right? Now you can also write this 5, 6 dimethyl hepta 2, 4 diene. Both of these will be acceptable. And I didn't write the condensed formula for this guy, but the condensed formula for this guy will be CH3, CH, 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 C, CH3, CH, C, so we got 1, 2, 3, 4, 5, 6, CH, and then this should be just CH3. We got our two ethyl groups there. Okay, let's take a look at C, and I'll try to go with the condensed formula first. So here we have what looks to be 1, 2, 3, 4, 5, 6, 7. That gives us 7. 1, 2, 3, 4, 5, 6 is not the longest. So now we're actually going to be numbering from the right side. So we're dealing with 1, 2, 3, 4, 5, 6, 7. And I did not do this on purpose to make all of these 7, but you get the point. We're going to have some more examples as well. So we end up with 1, 2, 3, 4, 5, 6, 7. And we have 3 substituents in this case and the double bond here. So iodo, bromo, and methyl. Bromo comes first. So we're dealing with 4 bromo. I comes before methyl, 3 iodo, 5-methyl hept 1-ene. Or, again, 4-bromo 3-iodo 5-methyl 1-heptene. Both of them are acceptable in this case. Both of them are acceptable. The condensed here, if we go from left to right, 7, we got CH3, CH2, CH3 side chain, CHBr, CHI, CH, CH2.